Okay, the chart shows the number of minutes students spent studying for a test and their grade on the test. Draw a scatter plot of the data. Which equation is the closest to the line of best fit? Now, fortunately for you, you're not going to have to draw a scatter plot because the calculator will find the line of best fit for you as long as you know how to do it on the calculator. The first thing you should do is type the list in. So more than likely everybody's is already typed in because we've been doing this all day. To type it in, you go to Stat, Edit, just like we do when we're trying to find stuff like mean, median, and mode. The numbers should already be typed in for you. Then after that, you go back to Stat, and you go over to Calc. But remember, we're trying to find the line of best fit. Look at all four answer choices. Aren't all four of these choices in the form y equals mx plus b? So look at your calculator now under Calc and tell me which one you think I'm going to choose. The what? This one. Doesn't that look just like mx plus b? They just use a for slope. So hit number 4. And now you have to make sure that it shows L1 and L2 because didn't we type in this column in L1 and then this column in L2? So make sure your calculator shows that. Yeah, L2 is right here above 1 and L2 is right there above 2, but to use them you have to hit second. And then you go down to calculate and press enter. Okay, it lets you know that A, which we know is M for slope, is 0.33, and then B, which is the y-intercept, is 52.4. So if our slope is 0.33 and the y-intercept showed up as 52.4, which equation would that be? B. 0.33 is the same thing as 1/3, and then 52.4 can round down to 52. So all you had to do was go to Stat, Edit to type the list in. Then once the lists are typed in, you go back to Stat, over to Calc, and then we're trying to do the line of best fit, and all lines are in the form y equals mx plus b, but they use ax plus b. You click it, you make sure it shows L1 and L2 because that's where you put your two lists. Then you go down to Calculate, and you have the answers right there. Let me see. Now we're going to be working on page 18. Turn to page 18. Yes. We're going to be skipping a couple of pages that we'll come back to. But for today, we're starting on page 18. All right. Determine how many and what type of solutions each quadratic has below. If possible, state the solutions. Okay, well, let's talk about some other things first. This parabola opens down. It's been reflected. And what caused that to occur? The negative. And isn't that negative like a -1 in the A place? And anytime your A value is 1, it's your standard size parabola. No vertical shrink or stretch has occurred. How many solutions does it have? 1, because it hits the x-axis 1 time. And where does it hit? 0. So that's the solution. All right, number 2. Why does this parabola open up? It's positive. And what is the A value? 1/2. Remember, when we're talking about quadratics and the A is less than 1, it's a vertical shrink, which is why this parabola is a little bit wider than the previous one. Now, how many solutions does it have? 1. It only hits the x-axis in one place, and that one solution is x equals 0. What? It's easy. All right, number 3. Number 3 is a little more difficult because they give us the equation in standard form. The solutions are harder to see. Like, watch when I zoom in. Let me zoom in a little further just to prove to you where does the parabola appear to cross through the x-axis? Well, look, here's negative 2. So is it actually crossing through at exactly negative 2? So it's negative 1 point, okay, some a little hard, negative 1.8 or negative 1.9. What about this other one? Okay, negative 0.2. Okay, the only way to know for sure would be to solve it. Now, the best method to solve one like this, where the A value is not the GCF, and look, if you tried to do the A times C method, 3 times 1 is 3, and then the B is 6, but are there two numbers that multiply to 3 and add to 6? No. So, what's the best method to solve this one? No, not complete the square. To do complete the square, you have to have an A value of 1. What's our most recent thing we learned? Quadratic formula. Remember, anytime you're trying to solve a quadratic, you use the quadratic formula. Right. Now, you don't have to write this down, just watch. The A is 3, the B is what? And the C is 1. When doing the quadratic formula, you first find the discriminant. And the discriminant is the b squared minus 4ac part. Everything up under the square root sign. So b is 6, a is 3, c is 1. Calculate that for me. $24. Okay, now, if your discriminant turns out to be a positive number, that means there's going to be two solutions. Well, we already knew there were going to be two because we see it cross the x-axis 2 times. Now, to find the exact location of those two x-intercepts, you continue on with the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, which we already did and got 24, all over 2a. A is 3, so that is a 6. Now type it in, negative 6 plus the square root of 24 over 6. Everybody type it in first with the plus sign. Yes, but we don't know. Whoever typed it in. Okay, so when you type it in with a plus sign, you rounded it to negative 0.2, which is what somebody said. Just by looking at the graph, they guessed. That was a good guess. What about when you type it in with the minus? Okay, did everybody type it in? Negative 1.8. So whoever guessed negative 1.8, that was a good guess. All right, number 4. Number 4, how many solutions does this parabola have? How many times does it hit the x-axis? So no solution. Guys, the solutions are the x-intercepts. So if it never hits the x-axis, there are no solutions. Now, can anybody tell me why that will occur? Okay, but think about if you tried to do the quadratic equation. Why would it occur? It would be negative, right. Think about it. If you type in the b squared minus 4ac, that becomes a 4 minus a 20, which is negative 16. Guys, you're not paying attention to the lesson. Turn around and focus. Then at that point, don't you have to stick that negative 16 up under a square root? And you cannot take the square root of a negative number. So that's why you end up with no solution. Okay. Now go to the next page. Number 1, state the solution and the factored form of the equation. For this parabola, how many solutions are there? Correct, because there's two x-intercepts. What are those two solutions? 1 and 3 are the x-intercepts. So we've done half the problem. We've stated the solution. They also want you to write it in factored form. How do you represent a solution of positive 1 as a factor? Very good. X minus 1. How do you represent a solution of 3 as a factor? Remember, when they're in factored form, they're the opposite sign, because think about it. From this to this point, don't you have to set it equal to 0 and add the 3 over? And set this equal to 0 and add the 1 over, which is why they end up positive 1 and positive 3? All right, number 2. What are the two solutions? Okay, so in factored form, that would be what and what? Right. Does it matter if you write the x minus 1 first and the x plus 3 second? No. All right, number 3. What do you mean? Because, you mean from here to here? Because in factored form, it's always the opposite sign. Because think about it. If this was set equal to 0, you would set the x plus 3 equal to 0. And to solve for x, you would have to minus the 3 away from it, which is why it ends up negative 3. Okay, what's different about number 3? There is no solution because there are no x-intercepts. But that does not mean there's no equation for it. If there's a parabola, there's an equation that made that parabola. Now, since we can't do it like we did the other ones, we can do it in vertex form. Y equals a times x minus h squared plus k. If we're trying to write it in vertex form, what's the first thing we should concern ourselves with? The vertex. If you're trying to get in a vertex form, you should probably figure out what the vertex is. The vertex is negative 4 and 3. So remember, let's not worry about the a yet. X, if you plug in a negative 4 for the h, a minus a negative 4 becomes plus 4. And then if you plug in a positive 3 right here, and that just plus 3. Now let's talk about how to get the a. To get from the vertex to the next point on the parabola, how much do you have to go up? Actually, just 1. See how this is 3 and that's 4? So 1 unit. Okay, I want you to take about 2 minutes and try 4, 5, and 6 by yourself. No. Shh, no, you've had plenty of time. What are the solutions? Okay, so the factors are, right. Okay, now for number 5, the solutions are 3 and 5, right? And so the factors are x minus 3 and x minus 5. Okay, for number 6, yeah, because it tells you up in the direction state the solution and the factored form. The solutions for number 6 are what? Okay, so in factored form that would be, right. Okay, go ahead and turn to page 20. Well, there's a few that are a little bit different. Okay, number 7. This time, what are the solutions? What are those x-intercepts? 0 and 4. Now, you obviously know how to write 4 as a factor. It's just x minus 4. How do you write 0 as a factor? Yes, you do. Just an x. Because think about it. No, think about it. If 4 is x minus 4, then 0 is like x plus 0, right? But you don't have to write plus 0, you just write the x. Okay, now try the rest of this page. I'll give you about 2 minutes to do the rest of this page. On number 8, how many solutions are there? And what are they? Negative 2 and 0. So that would be an x and an x plus 2. All right, number 9. The solutions are a negative 3 and a 0. So that would be an x and an x plus 3. Number 10, the solutions are -6 and -3. And so it's x plus 6, x plus 3. For number 11, there are no solutions because there are no x-intercepts. But we can still write this equation in vertex form. Okay, the vertex is left 4.5. Well, if your h value is -4.5, in the formula, wouldn't it be x plus 4.5? And then you have to go up 3.75. Okay, attention. Now, to get from the vertex to the next point, how much do you have to go up? No. If you're at 3.75, to get up to that line, you're just going up a quarter. 3.75 to 4 is a quarter. So 1/4. Yeah, because look, if you're at 3.75 right here, to get up to that line where the next point is, and that just up a fourth? So 1/4. Because you had to go left 4.5 to get to the vertex. Not on this test, no. You already had a test like that where there were problems like this. Number 12, what are the solutions? So y'all need to pay attention. And so the factors are what and what? Okay, next page. Okay, number 13. It crosses the x-axis in two places. So there's two solutions, -6 and -3. So just like we were doing on the previous pages, those as factors would be an x plus 6 and an x plus 3. But these parabolas are upside down, so you have to put a negative on the factor equation to represent that. All right, number 14. The two solutions are -1 and -4. So in factored form, that would be an x plus 1 and an x plus 4. But since it's open and down, you put a negative. Okay, try the rest of this page. Number 15. Marcus, tell us what you got for the solutions. +3. And so as factors, how do you write that? Good job. Okay, Josh, what are the solutions for 16? For 16? No solution. So let's talk about how to write that in vertex form. If you're trying to write it in vertex form, the first thing you should pay attention to is the vertex. And to get to the vertex, you have to go right how many? 1.5. And that's your h value. So wouldn't that be an x minus h, which is 1.5? And then you square it, which is what causes it to be a U-shaped parabola. And then you have to go down 1.5. So in the k place, you have a -1.5. Now for the a, to get from this point to that point, how much do you have to go down? No, from the vertex to this line, it's just -1/2, right? All right, number 17. Everybody got that? Number 17, what are the solutions? And so in factored form, that would be... Okay, number 18, what are the solutions? Okay, so as factors, that would be... Well, yes, -x because it opens upside down, and then x minus 1. Okay, now turn back to page 16. Page 16. Number 1, it says solve equations using any method. When you look at that trinomial, which method do you think of right away? Right, that's what I see right away. I see that the a is 5, and that's a number that all three of these can be divided by. So I divide them all by 5. which means 5 is the GCF, so you factor it out. What trinomial remains when you divide them all by 5? R squared minus 12. Now, the trinomial remains is one that we can do bubble method to, right? By looking for two numbers that multiply to negative 12 and add to negative 4. 6 and what kind of negative 6, positive 2. So if those are if that is the factored form, what are the final solutions? Right, and how could you check and make sure you've done it right? Graph it. When you graph it, it'll produce a graph that cuts through the x-axis at positive 6 and negative 2. All right, number 2. When you look at that trinomial, what looks like the best way to solve it, to factor and solve it? GCF, because that a value of 10, pay attention in the front, can be divided out of all three terms. So this becomes v squared plus 2v minus 8. Now that we've done that and we've factored out the 10, the trinomial remains. That remains just has an a value of 1. And so you can bubble method it by looking for two numbers that multiply to negative 8 and add to 2. So positive 4 and negative 2. So that means the actual solutions for this trinomial are a negative 4 and a positive 2. And now, besides those being the x-intercepts on the graph, what else is special about those two numbers regarding this trinomial? Aren't those the two numbers that if you plugged in the v places would actually make it equal 0? All right, number 3. Number 3, we can divide all of those by 2. And that means 2 is the GCF, so you factor it out, which is like undistributing it. And what trinomial remains? Plus 2x minus 48. Now you have a trinomial that has an a value of 1, because it's just 1x squared plus 2x minus 48. And we can bubble method those by looking for the two numbers that multiply to make the c and add to make the b. Negative 6 and positive 8. And so that means the final solutions and where it would cross the x-axis are, right, and those are also the numbers that when plugged in the x places of the trinomial would produce a 0. Number 4, what can you do first? Divide by 6. And so that's the GCF, so you factor it out. And so what's the trinomial that remains? And so now you do what? Bubble method by looking for two numbers that multiply to make a negative 3, and that's a prime, so there's only two numbers that multiply to make that. 3 and 1. But for those to add to a positive 2, positive 3, negative 1. So that means your final solutions are, right, and that's where the graph would cross the x-axis, and those are the numbers that when plugged in would make it equal 0. Number 5, last one I'm doing with you. What do we do first? Guys, these are easy if you just pay attention. Okay, what trinomial remains? And isn't that the exact same trinomial that remained in the previous one? So we already know the factors are a positive 3 and a negative 1, making the final solution and positive 1. Okay, the remaining 5 are homework. We have 4 minutes if you want to keep working. Otherwise, you can switch out.